looks like biofuel.
Many people fail to realize the mass amount of waste that the coffee industry produces. From the production of coffee, 500,000 tons of waste coffee grounds are typically dumped in landfills where they emit methane. Methane is one of the primary causes of global warming and is about 28 times more powerful than carbon dioxide at warming the Earth on a 100-year timescale. NC State currently composts their spent coffee grounds, but prior to popular belief, composting releases greenhouse gases from energy and waste used in the composting process.
Upon visiting a local coffee shop in downtown Raleigh, Sir Walter Coffee, we found that on an average day, they use anywhere from 70 to 80 pounds of coffee. And then after speaking to the manager, we learned that all of this daily waste ends up in landfills, where, as it breaks down, it is bound to release methane and other greenhouse gases. With Caf-fuel, our goal is to take used coffee grounds and create usable biofuel in an effort to decrease the NC State carbon footprint by preventing over 200 pounds of coffee grounds that's produced daily on campus from ending up in landfills, and instead turning it into a biofuel that can be used for the Wolfline.
To accomplish this, we will need to establish three main processes: collection, extraction, and distribution. In order to collect the spent coffee grounds, we will take designated bins to participating coffee shops on and off campus to effectively store the grounds. We would then pick the grounds up, which makes financial sense for NC State since it saves them money as it is cheaper than sending waste coffee grounds to a landfill. The grounds then arrive at our processing center to begin the extraction phase. Upon arriving at the processing center, the coffee is sifted so that it is more uniform and even in size. It would then be dried using a solar-powered kiln to help maintain the carbon neutrality of the process, and this would be a one-time cost. The grounds are then broken down with a mechanical press and placed in a mixer settler, along with N-hexane, which is a liquid-liquid extraction system that is an industrial cheap process. Essentially, the grounds will be mixed with the hexane in the first stage of the process, and then gravity will be used to naturally separate the coffee oil from the grounds. By the use of a rotary evaporator, we will remove the hexane to use it again with the next batch of coffee. Additionally, the remaining grounds are composted so they do not just end up in a landfill. Next, the oil would be put through transesterification, which is the technical process of bonding this raw oil with regular diesel fuel so that it can actually be used. The resulting product after this process is made up of about 1 part coffee oil to 4 parts diesel fuel. Ultimately, we are transforming waste to fuel.
This concept may seem like a stretch, but there's actually a company in London named Biobean that has been doing this. This group, with the help of College of London, has been converting waste from London coffee shops into usable biofuel for the London busing system since 2013. They successfully built and launched the world's first industrial-scale coffee recycling center, proving that this concept is in fact possible.
Here at NC State, we pride ourselves on being as sustainable as possible, always looking for new ways to be green. If we were to initiate the concept of coffee recycling on our campus, not only would we be the first to do so in the Triangle area, we would also be the first school in the nation to do something like this. Now, while coffee waste wouldn't always jump to the forefront of someone's mind when thinking of sustainability issues, there are actually some really convincing reasons as to why it should.
As a university, we found that NC State coffee shops alone currently produce a combined total of approximately 200 pounds of coffee waste per day. This is even with current reduced traffic, as can be attributed to the state of the ongoing pandemic. If we extrapolate this data, we can estimate a semester's total to be somewhere around 22,400 pounds.
Now, with referring to Biobean's documented production efficiency, which is approximately 2.7 ounces per pound of coffee processed, they would put us at being able to extract 472.5 gallons of usable oil in a COVID-affected semester. When we factor that this is then combined in a 1-to-4 mix with diesel fuel, we find that in a semester we could extract enough oil to mix approximately 2,362.5 gallons of coffee stimulant diesel fuel. That alone is enough to fill 9 Wolfline buses.
This doesn't even take into account the possibility of off-campus partnerships like Sir Walter Coffee. Lastly, while going through many iterations, we feel certain our production process is effective for mass quantities of coffee grounds due to insight from faculty in NC State's Chemical Engineering Department. If NC State adopts the plan that we have designed with Caf-fuel, they will be the model university for sustainability in the United States.